Hello students, and welcome back to another geometry video. You know what to do. Pause the video and try this problem in your notes, then unpause it to do it with me. So we are asked to describe and correct the error in this problem. So someone has done something wrong and we need to figure out what it is. So because DE equals 1/2 of BC. We can see that. DE is 5 and BC is 10. So, by the triangle midsegment theorem, that must mean that AD is equal to DB and AE is equal to EC. Well, hang on a second. The triangle midsegment says that if I have a midsegment, then DE is equal to 1/2 of BC, or then the midsegment is half of the third side. So this is the other way around, and this is not necessarily true. We can tell just by looking at this that AD looks shorter than DB. AE, this looks like it could be the same in my mind, but we can tell that this side is not perpendicular to the third side. So this is not truly the midsegment of the triangle. So what we would write is DE may be equal to 1/2 BC, but this is not a midsegment because it is not parallel to the third side. Awesome, there we go. That's a nice little review from yesterday. Let's see what we have for today. Today we are starting 6.5, and we're actually only going to spend one day on 6.5. This is about inequalities in one triangle. I know it says indirect proof and inequalities in one triangle. We're actually not going to talk about the indirect proof part of 6.5 in this video. Maybe in a future video, but not right now. So we are just going to focus on inequalities in one triangle. So what we're curious about is how are the sides related to the angles of the triangle? And how are any two sides of a triangle related to the third side? So we're going to be answering these two questions in this video. Now our learning target for this video is that you know what the Triangle Inequality Theorem is. That's the main takeaway from this video. Our success criteria is that you can list sides and angles of a triangle in order of their size. Biggest to smallest, smallest to biggest. And you can use the Triangle Inequality Theorem to find possible side lengths of triangles. So, what are the possible lengths of a triangle given certain information? So that's what we're going to be doing in this video. Let's go ahead and get started with two theorems that we're going to use in the next couple of examples. So, Theorem 6.9 is the triangle longer side theorem. And what this says is if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So this is the most important part. The angle opposite the longer side is larger. So if I know that BA is bigger than BC, that means that angle C, which is opposite of the 8, angle C must be bigger than angle A, because the side opposite angle A is smaller than the side opposite angle C. And this works the other way around as well. So if we look at the triangle larger angle theorem, if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So this is kind of like the converse of what we just talked about. If one angle is bigger than another, the side opposite the bigger angle is bigger than the side opposite the smaller angle. So because 50 is the bigger angle, BC is going to be the bigger side. Because 30 is the smaller angle, AB is going to be the smaller side. Small, big, relatively small, relatively big. Okay, and this makes sense. If we want to stop and think about why does this make sense, if I'm creating an angle, if I open my arms, I'm making this angle wider. The larger I make that angle, the more I open my arms, the farther apart my hands are. So you can think of like right where my elbows meet as the vertex of the angle, and the distance between my hands would be the side length. So the bigger that this angle is, the farther away my hands get from each other. So that's some intuition for why these theorems are true. Now, let's do some examples using these theorems that we just learned. You are constructing a stage prop, for a musical or a play of some sort, that shows a large triangular mountain. That's what JKL is. The bottom edge of the mountain is 32 feet long. The left slope is about 24 feet long, and the right slope is about 26 feet long. List the angles of triangle JKL in order from smallest to largest. So, we're going to put our small angles on the left and our bigger angles on the right. So, what I'm going to do is I'm going to find the smallest side length. Let's see, 24. 24 is the smallest number of all of these. So 24 is the shortest side, which means that the angle opposite that side is the smallest angle. Angle L is the smallest angle because it is opposite the smallest side. Now let's find the biggest angle. Well, the biggest angle is going to be opposite the biggest side. And 32 is the biggest number, is the biggest side length. So the angle opposite this side, angle K, must be the biggest angle. All right, and notice that we have not talked about angle J yet. Angle J is the only angle that is not in this list. And the side opposite angle J is right in the middle. It's bigger than 24, but it's smaller than 32, which means that angle J is neither the smallest nor the biggest, it's right in the middle. So, if we wanted to list the angles in order from smallest to biggest, there you go. Angle L is the smallest, angle K is the biggest, and angle J is in between them. Ta-da! Let's check and see if we were correct. Angle L, angle J, and angle K. Boom! We were correct. And this is by the triangle longer side theorem, of course. Alrighty. I'm gonna move out of the way so you can see the whole thing if you want to. Alright, let's move on to our next example, ordering side lengths of a triangle. So now they gave me some angles and I need to know what sides are smallest, or are shortest and longest. So we're gonna put the shortest side over here, and we're gonna put the longest side over here. So, in order to know what is the shortest side, I need to find the smallest angle. But wait a minute, what's angle F? How am I supposed to list these in order when I don't know all the angles? Well, wait a minute. Is there a way that we can find angle F? How many degrees are there inside of a triangle? 180. So I can take whatever 51 plus 47 is, and I can subtract that from 180. So 51 plus 47 is 98, and 180 minus 98 is 82. So F is 82 degrees. Okay, now I can list my sides in order from shortest to longest, because now I know all the angles. Okay, so if I want to find the shortest side, let me find the smallest angle. Let's see, 47 is the smallest number here, so it is the smallest angle. That means that the shortest side is the side opposite of that angle. So side DF is the shortest side. Now, let's figure out what the longest side is. The longest side is the side opposite the biggest angle. The biggest angle is 82 degrees, because that is the biggest number. And the side opposite 82 degrees, or opposite of angle F, is DE, side DE. Now, the side in the middle, we found the shortest side, we found the longest side, but what about the in-between side? What about the middle-sized side? Well, angle D, 51 degrees, is in between 47 and 82. The number 51 falls in between 47 and 82, which means the side opposite of angle D is our in-between side. So side EF is neither shortest nor the longest. So if we want to list them in order, DF is the shortest, EF is a little bit longer, but DE is the longest. There you go. There you go. Let's check and see if we were correct. DF, EF, and DE by the Triangle Larger Angle Theorem. Woohoo! Okay, now it is time to move on to the Triangle Inequality Theorem. So this is one of the more important things that we're going to talk about today. The other two theorems were a little bit intuitive. You could kind of, guess them just by looking at a triangle. You could kind of guess that that was true, maybe. The Triangle Inequality Theorem, you could also do that, I suppose, but I think it's less intuitive. So, the Triangle Inequality Theorem says the sum of the lengths of any two sides of a triangle is greater than the third side, or than the length of the third side. So, in every triangle I have three sides. That's the definition of a triangle. So if I take any two sides, I could take the red and the blue side, I could take the green and the blue side, I could take the red and the green side, doesn't matter. Any two pairs of sides, when I add them together, I need to get something that is greater than the third side. So if I add the red and blue together, I'm bigger than the green. If I add the green and blue together, I'm bigger than the red. If I add the red and green together, I'm bigger than the blue. Notice how this does not say greater than or equal to. And we're going to talk more about why it is not equal to in the next slide. Understanding the triangle inequality. Why is this true? Why is it that when I add two sides of a triangle, it needs to be bigger than the other side? Well, not every group of three segments can be used to form a triangle. the lengths of the segments must fit a certain relationship. That certain relationship is the triangle inequality theorem. So for example, 3 attempted triangle constructions using segments with given lengths are shown below, and only the first group forms a triangle. So notice that if I have side lengths 4, 2, and 5, that makes a triangle. I can see right here that all the sides meet at a vertex, all the sides are connected, I have a triangle. If I look at the middle example here, I have a side length of 5, and then I have 2 and 2. And no matter how I swing this side, so that's what this red arc means here, it's saying no matter if the side that's 2 units long, no matter if that's here, no matter if it's here, no matter if it's here, no matter if it's here, no matter where the end of the segment falls on this red arc, it's not gonna connect with the other side. So this red arc is where the end of this segment could be, and notice that neither of these segments are going to meet each other. They're going to miss each other. The tips of my fingers will never meet if I rotate my arms from this distance. So this side, the side length 5, would need to be shorter in order for my fingertips to be able to touch. And you can see that if I add these two sides together, it should be greater than 5 in order for me to have a triangle, but 4 is not greater than 5. So that's why this example does not work. Another example you can see, the last one, this is why we cannot be greater than or equal to. We have to be strictly greater than, is because in this third case, see the arcs that this segment could end on. The only place where 3 and 2 will meet up is right on the other side. Well, if I lie these segments down flat, I don't have a triangle, I just have a line. It's like I have to lie them down until they're completely flat. Well, then they're just on the third side. So, if I am greater than or equal to, right, like 3 plus 2 needs to be greater than 5. Well, if this were greater than or equal to 5, I could have this case where the sides, the 2 of the sides are just equal to the third side. And that's not helpful. That's still not going to give us a triangle. So that's why this doesn't work either. So, when you start with the longest side and attach the other 2 sides at its endpoints, you can see that the other 2 sides are not long enough to form a triangle in the second and third figures. So this is where the triangle inequality theorem comes from. It comes from starting with the long side, attaching the other 2 sides at its endpoints, and seeing where could this segment end, and will it reach? Will they reach each other, or will they just miss? They won't be able to touch. So this is where the triangle inequality theorem comes from. Now let's move on and do an example with the triangle inequality theorem. So, we are asked to find possible side lengths. Ooh, this was the second part of our success criteria. So, a triangle has one side of length 14, one side of length 14, and another side of length 9. Excuse me. Describe the possible lengths of the third side. Well, we could, so there's 2 different cases here. We want to find what is the smallest number that x could be, and what is the biggest number x could be. So what if x was like the biggest side? Then we have 14 and 9. So x could either be the smallest side or it could be the biggest side. It could be the side in the middle, but we want to know all of the possible lengths. So in the end, we want to be able to say that x should be bigger than some number. X should be bigger or equal to the smallest possible side, and x should be less than, not or equal to, we just talked about that, not or equal to, or smaller than whatever the biggest possible side is. So we want to find the smallest and biggest possible sides. Smallest possible and biggest possible. So, in order to find the smallest possible side for x, we would need for x to be shorter than 14. That makes it the smallest possible side. So then, that means that x plus 9 has to be greater than 14. Right? Because the Triangle Inequality Theorem says I should be able to add any two sides together and have it be larger than the third. Now, if I looked at these sides and I said x plus 14 needs to be bigger than 9, well, we know that's going to be true. 14 is already bigger than 9. So if I'm adding a positive number to 14, duh, it's going to be bigger than 9. And I know x is a positive number because a side length can't be negative. So x plus 9 needs to be bigger than 14. And hey, if we think back to algebra, we know how to solve an inequality like this. I'm just going to subtract 9 from both sides. And we see that x must be bigger than 14 minus 9 is 5. So x has to be bigger than 5. Okay, so that's the smallest possible side. X could be 5, and that is the smallest that x could be. Or sorry, x can't be equal to 5. X needs to be bigger than 5. So 5.00001, something close to that, is the smallest possible side. Alright, now if x is supposed to be the biggest side, we need to make sure that when I add the other two sides together, when I add 9 and 14 together, that still needs to be bigger than x. So, 9 plus 14 is 23. So x has to be bigger than 5, but it also needs to be smaller than 23. So, x needs to be bigger than 5, but smaller than 23. There you go. So anytime you want to know the possible side lengths of a triangle, you want to look at what could the smallest possible side be and what could the biggest possible side be. And that will help guide your work through the problem. Let's check and make sure that we were correct. Small values of x, x is bigger than 5. Large values of x, x is smaller than 23. So the length of the third side must be greater than 5 and less than 23. Booyah! And oh hey, look at that. They said you can combine two inequalities to write the compound inequality. That's what we did. We already wrote one of those. Okay, wonderful. That is all I have for you today. So at this point in the video, now is a great time to assess your understanding of the learning target and the success criteria. Do you understand the larger side theorem, larger angle theorem, the triangle inequality theorem? Do you understand the theorems that we talked about in this video? And do you know how to use them? Can you list angles and sides in order from biggest to smallest or smallest to biggest? And can you find the possible side lengths for a triangle? So if you are utterly confused, please, please, please ask questions. If you think you got it but maybe aren't too confident, that's okay. You're ready to start the homework. Ask questions if you need to. And if you are super confident, good to go, well, do your homework, help your friends, help your siblings, teach your parents what you've learned. And here are some practice problems that you can do to practice the skills that you have learned in this video. Now, these last set of problems, we didn't do an example explicitly like these, but these use the Triangle Inequality Theorem. So, you can use the Triangle Inequality Theorem to help you with 21 through 24. All right. And of course, let's end our video with a launch, shall we? So today's launch comes from Rick Riordan. I hope I pronounced that right. And he says, if there's one thing I've learned over the eons, that's a joke about him being old, it's that you can't give up on your family, no matter how tempting they make it. So, no matter how tempting they make it, family can be annoying, right? Your little siblings can be really annoying, your parents can be annoying, but you can't give up on your family. Now, when we say you can't give up on your family, does that mean that you can't take some space from your family? Absolutely not. If you need to take space from your family, if your family is not being helpful for you, you have, every right and you have the ability to take a break from your family. After you're 18, of course. Unfortunately, not much you can do before then unless, bad stuff is happening. But, so you have permission to take a break from your family, or to not talk to your family for a while, or to set boundaries with your family, obviously. But don't give up on them. Your family is your flesh and blood, and your family knows you better than like anybody else. Even if you don't necessarily have a good family, never give up on them. Because the relationships that you have with your family members can be some of the richest, best relationships that you will have in your life. So remember, set your boundaries, take care of yourself, but also don't give up on your family. Give them a second chance, give them a fourth chance, within reason, of course, and build lifelong relationships that will mean a lot to you in the end. So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.